1. Opening scene. It's 2:45 a.m. The house is so silent you can hear the hum of the refrigerator 3 rooms away. Beside you, your dog is deep in the heavy, slack-jawed state of true exhaustion. But then, it starts. A muffled, high-pitched yip escapes their closed muzzle, a sound they never make when they're awake. Their paws begin to paddle against the air, rhythmic and frantic. Their whiskers twitch, and behind their closed eyelids, you can see their eyeballs darting back and forth in a frantic, jagged dance. Most people look at this and smile, whispering to themselves, "Oh, they must be chasing a rabbit." We assume it's a simple, cute leftover of a predator's instinct. But behavioral neuroscience tells a completely different story. What your dog is doing right now is one of the most complex expressions of cognitive architecture in the animal kingdom. They aren't just chasing something. They are performing a high-speed, structural rebuild of their own reality. They are reliving their day, frame by frame, to decide what's worth keeping and what's worth forgetting. And most owners have no idea that this cute which is actually the engine of canine intelligence. 2. Dismantling the obvious explanation. Let's start with the rabbit theory, because it sounds reasonable. We see the paws moving, we assume a chase. It's the simplest explanation for a predatory animal. But here's the problem: if your dog were simply replaying a hunt, the motor patterns would be consistent across all dogs. But they aren't. A golden retriever's dream twitches look different from a greyhound's, which look different from a pug's. The answer isn't about the rabbit. Furthermore, it's about the map. If it were just about your dog's chasing, brain is a why do they do it even if they've spent the entire day on the couch? They are bombarded with millions of sensory inputs. Why do dogs that have been blind from birth show the exact same rapid eye movement when you said walk patterns as dogs? Sleep is the only time the brain has the bandwidth to sort. So why do their bodies insist on running? They aren't choosing to run. Their brain is firing the exact neurons required to navigate their world, testing the connections to see if they hold. 3. Scientific foundation number 1, the MIT breakthrough. To understand what's actually happening behind those flickering eyelids, we have to look at a landmark study from the Massachusetts Institute of Technology, MIT, in 2001. Researchers Kenway Louie and Matthew Wilson studied the hippocampus, the part of the brain involved in memory, in animals during sleep. They trained subjects to run through a complex maze for a food reward and monitored their brain activity. What they found was extraordinary. When the animals entered REM sleep, their brains began firing in a pattern that was nearly 100% identical to the pattern recorded while they were actually running the maze. The signature of the brain activity was so specific that the researchers could actually tell which part of the maze the animal was dreaming about and whether they were running or standing still in the dream. Key phrase: when your dog twitches their paws, they are performing the single most fundamental behavior in memory consolidation. They are literally rerunning the maze of their day. They are practicing the way the floor felt under their paws at the park, the trajectory of the ball you threw, and the specific sequence of events that led to a treat. They aren't being active in their sleep, they are telling you that their life with you is so complex and meaningful that it requires a second, nocturnal rehearsal just to process it all. 4. Scientific foundation number 2, neurochemistry. But here's where it gets really interesting. Because this isn't just about what they are dreaming, it's about why they don't actually get up and run into a wall. This is a miracle of neurochemistry. In a study published in the journal Nature Neuroscience, researchers at the University of Lyon, led by the legendary Michel Jouvet, identified the paralysis switch in the brain. Within the brainstem, there is a structure called the pons. During REM sleep, the pons sends a signal down the spinal cord to shut down the large muscles. It uses 2 primary chemicals, acetylcholine, which triggers the vividness of the dream, and glycine, which acts as the inhibitor. This is a delicate chemical balance. The twitches you see are the leaks. The dream is so intense, the neuronal firing in the motor cortex is so powerful, that it occasionally overrides the glycine block. This co-evolved specifically to keep social animals safe. Wolves and dogs sleep in groups. If every dog acted out their dreams of hunting, the pack would be a chaotic, dangerous mess of snapping jaws and flailing limbs. Now think about what happens over the 12 to 14 hours a dog sleeps per day. Unlike humans, who have one long sleep cycle, dogs enter REM much faster, usually within 20 minutes. Because their sleep is fragmented, their neurochemical cleansing happens in bursts. Each twitch is a tiny surge of acetylcholine, a momentary victory of the dream over the paralysis. 5. Evolutionary/historical context. When did this complex dreaming start? The answer is basically from the beginning of mammalian life, but it became specialized in dogs over the last 15,000 years. If we go back to the pre-agriculture era, the dogs, or proto-wolves, that were the best learners, were the ones that survived. Evolution favored the animals that could process the day's lessons offline. Archaeological evidence from ancient burial sites shows that early domestic dogs were often buried in positions of rest, sometimes with their heads resting on their paws, much like they do on your bed tonight. Genetic evidence shows that dogs have a highly developed prefrontal cortex compared to other carnivores of their size. This extra brain real estate is dedicated to social cognition. They weren't just dreaming about hunting, they were dreaming about us. Because dogs moved from the forest into our homes, their survival mazes changed. Instead of, "Where is the deer?" the maze became, "What does it mean when the human grabs the metal jingly things?" The keys. Your dog isn't doing something unusual. They are using an ancient survival mechanism to solve the most modern puzzle of all, how to live in harmony with a completely different species. 6. The counterintuitive study. Now, I want to tell you about a study that nobody talks about because the finding seems impossible at first. Dr. Stanley Coren, a professor of psychology at the University of British Columbia, conducted extensive research into canine sleep cycles and found a bizarre correlation. Size matters, but not in the way you'd think. You would assume a large dog, like a Great Dane, would have massive, long dreams. But Coren found that small dogs, like Chihuahuas or toy poodles, actually dream much more frequently. A small dog might have a new dream every 10 minutes, while a large dog might only dream once every 90 minutes. However, the large dog's dreams last significantly longer. How is that possible? The theory is that it's linked to the speed of their biological clock and their metabolic rate. Small dogs process the world in high-speed bursts, while larger dogs process in long-form narratives. And here is the deeper truth: regardless of size, Dr. Deirdre Barrett of Harvard Medical School suggests that since dogs are so intensely attached to their humans, they are almost certainly dreaming about your face and your scent. There is no negative data here, just a different rhythm of processing the same shared life. 7. The synchronization discovery. And this is where it gets deep. A recent 2023 study on interspecies sleep architecture found that when dogs sleep in the same room as their owners, their REM cycles often begin to synchronize. Using non-invasive sensors, researchers found that if an owner has a particularly restless night, the dog's dream twitching increases. Their nervous systems are listening to each other, even in the dark. This only happens within bonded pairs. If you put a dog in a room with a stranger, their sleep remains shallow and they rarely enter the deep, twitching, REM phase. This reveals a profound statement: your presence is the permission slip your dog needs to dream. They only feel safe enough to enter that vulnerable, paralyzed state of deep memory sorting because they know you are there. The dream running, you see, is a sign of ultimate psychological safety. 8. The warning section. There's one last thing I need to tell you, and it might be the most important part of this video. While the 2 a.m. twitch is usually a sign of a healthy brain, there is a serious tone shift we need to address. You need to know the difference between a dream and a seizure. Dreams are fluid. The legs move, the tail might wag, the sounds are soft huffs. Most importantly, if you gently call their name, a dreaming dog will usually startle, awake and recognize you immediately. But if your dog has been dreaming normally for years and suddenly starts having episodes where their body goes completely rigid, where they urinate or defecate involuntarily, or where their eyes are open but glassy, and they don't recognize you when they wake up, that is not a dream. Dogs are creatures of habit. When a twitch turns into a stiffness, it could be an early sign of neurological decline or idiopathic epilepsy, which affects roughly 0.75% of the dog population. Your dog doesn't have language. Their sleep patterns are the canary in the coal mine for their brain health. 9. Emotional closing. So the next time you wake up at 3 a.m. and see those paws paddling through the air, remember what's actually happening. You aren't just watching a chase. You are watching 15,000 years of evolution refining a map of your life together. You are seeing a neurochemical loop, a balance of acetylcholine and glycine, that keeps them safe while they explore the theater of their mind. Summary: The MIT study proved they are reliving their day. The Harvard research suggests that day is centered around you. All pointed at one thing: those little twitches are the sound of your dog saying, "I'm learning how to love you better." And honestly, the science suggests that when you sleep, your brain is likely doing the exact same thing for them. 10. Call to action. If this changed how you see your dog's sleep, subscribe to Mindful Paws, and drop a comment below. I want to know, what's the funniest sound your dog has ever made in their sleep? And if you want to understand why your dog circles 3 times before they lie down, that's the next video. And the science behind that ancient ritual is even more fascinating than the dreams themselves. See you in the next one.